Oh, hello, in this lesson, we're going to prove the fundamental theorem of calculus part 2. So let's look at the statement we're about to prove, that f is continuous on a closed interval, then the definite integral between a to b f of x is equals to capital F of b minus capital F of a, where capital F is any antiderivative of a lowercase f, i.e. capital F is the same, the derivative of capital F is equals to lowercase f. So, okay, we know that from the fundamental theorem calculus part 1, right? If we assume g of x is equal to the integration, right? With some minor changes here, g of x, f p here. This function is an antiderivative. Okay, so g of x constructed this way is an antiderivative of lowercase f, right? Because fundamental theorem of calculus part 1 has proved that g prime is f of x. And now we have capital F, right? With the capital F, oops. Okay, so let me rewrite this. It doesn't look nice. So f prime is also equals to f of x. According to a theorem we learned in the section of mean value theorem, okay? We have f has antiderivative g. G is antiderivative, capital F is antiderivative. So these two, right? Basically, this tells us that g prime of x is equals to f prime of x. So these two functions will be just different by a constant. So we have learned that theorem before. So this will be equal to g of x plus a big constant. Okay, so we got this relationship. Okay, so for all of the x, of course, in between a and b. Okay, hold on. For a less than x less than b. So this will be true. So now we're going to do a couple simple calculation. Okay. First of all, put my glasses. By taking limits on both sides, because x can be as close as possible to a, right? So when we take limit, this still be true. So this will be true for all of the x inside AB. Okay, this will be true for all of the x inside AB. Okay, we kind of wave our hands about it, right? It's true, okay? Now, knowing this relationship, right? So we're gonna find out what is g of a, right? G of a, if x equals to a, and this is going to be 0, right? What is g of b? This is g of b. And that's is the same as this, right? So that's the same thing. that would be the same thing. The only difference is that one is x, one is t, right? So they're gonna give us the same result. And now we're gonna do this. Capital F. Okay, capital F, plug in the B, subtracting capital F plus substitute by A from this relationship, right? So what do we get? Capital F minus, so that's gonna be, so from this relationship, this is gonna be G of B plus C subtracting G of A. Okay, G of A plus that constant. Okay, open up the brackets. Open up the brackets. We get minus C. So C and C makes 0. So we got G of B minus G of A, right? And G of A was 0. G of A was 0. So we just have a G of B. And what is G of B? G of B is that. This proof is pretty straightforward as it is a direct result of fundamental theorem of calculus part 1. So by this time we have proved fundamental theorem of calculus part 2. And the main thing is that we're going to use it. We're going to use it a lot. Okay? So that ends this recording, which is just for the proof of fundamental theorem of calculus part 2. Thank you for watching.